drill for deep learning. Today I'm going to see the thing called what is transfer learning. Transfer learning, there will be a lot of definitions there, but it's one of the formular learning technique in machine learning also, and come under the category of deep learning. And thing what you can say, transfer learning you can say pre-trained model. If you have anything, you can pre-trained model and reuse for solve the new problem. If you have a new problem, you can solve with the help of transfer learning also. Today I'm going to see just what is transfer learning and what is the difference between transfer learning and fine tuning, how to implement simply the transfer learning. At last, one example of transfer learning. So what is transfer learning? You can say is a reuse of predefined model and a new problem. Just now I told you. Moreover, it's a technique that works in a image classification task and natural processing task also. And let's say example, I have if you have, want to classify the images of dogs and cats. Suppose in your classification, I want to classify the images of dog is there and the cat is there. So if you want to identify, you can go for transfer learning. So later, after giving the training with the help of transfer learning, you can identify the things whether it's a dog or not. Predict and say dog, say dog. If cat means say cat like that. Moreover, we can say we can train a classifier where to predict whether a image contains food or to reduce the knowledge it gained during training to recognize drinks. Or else, if you have food, there will be a table in your plate. There will be food is there and cool drinks is there. We can identify later after giving the training. So pre-trained only, and these models can be directly used in making predictions on the new task or integrated into a process of training a new model. And it's particularly useful and popular today because the small training data set. If any training data set, we can go for this. And also we can use weight from the pre-trained model to initialize the weights of the new model also. The general thing. Source model and source data, some large amount of then transfer learned knowledge, target here is the target data, target model and target labels. So small amount what I'm there. So again repeating, if any image classification task, if you have small or big not a matter, if at all very small, very convenient transfer learning where you can apply transfer learning and go for predict it. Whether you want to predict and suppose you have images of dogs and cat, you want to predict only dogs, you can go ahead. So you can go and predict the dogs images. After some time, if you want, you can go for cat. If you want cat also, you can go and predict the cats also. That is possible. And what is the difference between transfer learning and fine tuning? So fine tuning, one of thing where you can say optional step in transfer learning. If you want, you can go ahead with the transfer learning because it usually improve the performance of the model. We have model, so everyone go behind with the CNN and everything. If you design a model for your data set, you can go improve the performance. For the time we need support of this fine tuning concept. It's optional. So just see the diagram, we have fine tune. So already the model is bad and the CNN we are applying CNN and where convolution block is there followed by EPC layer, full connected layer is there. But already in the previous session I explained about CNN. Why? Because fully connected layer is a layer where responsible for predictions at last what our model could predict. And if you go fine tune, this is the transfer parameter where we can go fine tune where it consists of a so convolution is there, convolution of frozen or not is there, and convolution block is there, FC layer is there, new and label. So we are adding something here, we are transfer parameter there, we are doing some modifications and go fine tune, again repeating fine tune for improve the performance of the model. For example, your model giving 98, after going for 98% means if you improve it with the help of fine tuning, it may say 99 also. Then how to implement transfer learning? So these steps is there: train CNN on the ImageNet and replace the layer, continue network training and measure classification accuracy and select best CNN and indicate with the tracking. So these are things. The upcoming session go for practical session. That time you can understand easily. So train CNN and replace, continue networking, measure classification accuracy, at last best CNN indicate with the tracking. So here we just now told you there are, if you want to implement, 6 steps are important here. One is called obtain the pre-trained model, that is the model where you'd like to use of a problem. For based on the problem, we can predetermined model like that, and create a base model. You usually have more units in final output layer. Remember, when creating the base model, you have to concentrate more because you have to remove the final output layer here. Next step is so obtain the pre-trained model and create a base model. Another first step there. Another one called like look like this. See, remove the classifier, add softmax layer with the 3 units. So everything will get clarity when you go for a practical session of transfer layer, and freeze layers so that they won't change during training. Here, there will be no difference from training the model from scratch. Example, like say base model is equal to base underscore model dot trainable is equal to false also. Here, this is required for some time only, and this is the one freeze layers. So C1, C2 convolution layer is there, followed by a fully connected layer is there, and training first time. And add new, another step is called add new trainable layers. Here the add new trainable layers that will turn old features into a prediction on the new data set. So this is important because the pre-trained model is loaded without the final output layer, remember. So here the one task we are going to say, again repeating, TransferLearning pre-trained only, already have a training data, we can add the new task and for the data set and go for it predictions. So this general diagrams given for new FC layer, original layers and old FC layers. So input convolution, just now told you, even with fine tuning also like look like this only, and train the layers on the data set. So here already told you this is important one, train the new layers. If you want, you can add new layers and trained on based on ImageNet with the help. We can categorize 1,000 classes and so on. So once add the new dense layer also, we can final dense layer units to the number of outputs expected by the model. So we can get the expectations here, prediction expectation, and improve the model via fine tuning. So just now told you, if you have 98% accuracy, you want more 98.2 or 99 also, you can go ahead with this up. This is optional one where the the main thing is the low learning rate will increase the performance of the model on the new data set while preventing the overfitting also. And examples, at last we go for example, transfer learning vision, where we can say image data. In computer vision, as of now, everything image only. You can deal with image or video data also. Here, because once go for deep learning, it's everything important here, images, audio, video, everything. Because generally people don't train the networks from the scratch. But once go for this one, what happen means the researchers who develop the models for the type of competition release the final model weights so that can use it under a permissive license also. So some of the examples of transfer learning general available today is called Oxford VGG model, another called Google Inception model. I hope that you understand today what is transfer learning and why is so important, and how to implement the transfer learning and so on. If you like the video, please subscribe and share with your friends. Thank you for watching the video. Thank you.